Yes, guys, to reinforce our understanding as far as the laws of exponents is concerned, I have these typical examination questions that I've extracted from the past examination papers. I've extracted these questions from the syllabus D 4024 O-level mathematics. So as we go over these typical examination questions, I'm going to explore or to unfold the concepts around the laws of exponents and also other algebraic concepts. So here is the first question. Question number 1, it reads, evaluate 5 to the power of 2 plus 5 to the power of 0. I've seen some students making a serious mistake, a mistake of immediately keeping the base and start adding the powers. This is completely wrong. You can only do that if you see that you are multiplying the powers with the same base. That's when you can keep the base and add the powers. In this case, you're not multiplying. Instead, we are adding. So it is academically or mathematically prudent to simplify each and every term. In this case, 5 squared gives us 25. Remember, 5 squared basically means 5 times 5. So that gives us 25 plus 5 to the power 0. We know that any number raised to the power of 0 gives us 1. So indeed, in this case, 5 to the power of 0 is 1. And you say 25 plus 1, you get 26. So 26 is our answer. In this next problem, 1 over x in brackets to the power of minus 2. Remember the law, it clearly specifies that when a term raised to if you have a situation whereby you've got a negative power, say a to the power of negative m, this is the same as 1 over a to the power of positive m. So in this case, this is the same as 1 over x. This is our base. We keep it as it is to the power positive 2. So this is the same as 1. Let's keep our 1 over. What is 1 over x in brackets to the power of 2? Remember, if I say ab in brackets to the power of m, this is the same as raising each number to that power. So this is the same as a to the power of m over b to the power of m. So here 1 to the power of 2, we get 1. And then x to the power of 2, we get x squared. So I understand that it's quite confusing. If you try to read this, it's read as 1 over x squared. But practically, this is simple. Why am I saying so? Because if I say 10 over 5, mathematically, this is the same as 10 or divided by 5. So if I say 1 over x squared, this is the same as 1 divided by 1 over x squared. And remember, if you're dividing fractions, keep the first fraction, which is 1 or 1 over 1, and multiply by the reciprocal of the second fraction. So the reciprocal here is x squared over 1. So straight away, you can see that if you say 1 times x squared, you get x squared over 1. So the answer is basically x squared. So that's our answer on B part 1. If we go on part 2, we have x to the power of 6 to the power of half. So remember, there is a law, and this law, it says that when a power is also raised to another power, like here you're saying a to the power of m, to the power of n. So it was a power to a power. So we keep the base according to the law, and we multiply those powers. So in this case, we need to keep our base. Remember, our base in this case is x. So we multiply the powers 6 times half. What is half of 6? We get x to the power of 3. So x to the power of 3 is our answer. So this is how we were supposed to tackle question number 1. Let's quickly move on to question number 2. So on question number 2, as we see here, question says evaluate 17 to the power 0. We know that any number raised to the power of 0 gives us 1. So indeed, 17 to the power of 0 is 1. And the next one, 4 to the power 3 over 2. This is basically the same as 4 to the power 1 over 2 to the power 5. So you need to take the number on the numerator outside. because it's very easy to find a number to the power 1 over n. Remember, if it is 1 over 2, it means square root. If it is 1 over 3, it means cube root. If it is 1 over 4, it means fourth root, etc. Like now, what is 4 to the power of half? It means the square root of 4, right? It means the square root of 4, and then we keep this 5. And what is the square root of 4? Inside the brackets here, we get 2. So this is same as 2 to the power 5. And 2 to the power 5 means 2 times 2 times 2 times 2 times 2, which gives us 32. So the right answer here, we get 32. And on the next one, we have 0,2 to the power of minus 2. Remember, 0,2 is basically the same as 2 over 10 as a fraction to the power of negative 2. So this is the same as 1 over 2 over 10 to the power of positive 2, which gives us 1 over 4 over 100. Right? And this is the same as 1 divided by 4 over 100, which is the same as 1 times 100 over 4. And straight away, we get 25 as the answer. So this is how we're supposed to tackle this question. In the next problem, which is question number 3, as we see here on question number 3, they say evaluate 9 to the power of 0. Any number raised to the power of 0, it's 1. And what about 9 to the power of minus 2? It's the same as 1 over 9 to the power of positive 2, which is 1 over 81. And on the next one, this is the same as 9 to the power half in brackets to the power of 3. Remember, I said if you have 8 to the power m over n, right? This is a to the power 1 over n. Take the m outside, right? Because it's easy to find 8 to the power 1 over something. If it is 1 over 2, it means square root. 1 over 3 means cube root, etc. So in this case, we are going to find the square root of 9, right, to the power of 3. And the square root of 9 is 3. And 3 to the power of 3 is basically 3 times 3 times 3, which gives us 27. So our first answer here, after applying that 8 to the power of 0, it's 1. Any number is to the power of 0, it's 1. We got 1. On the second one, we got 1 over 8. 8 to 1 after applying the laws of negative powers. Remember, 8 to the power of negative m is the same as 1 over 8 to the power of positive m. So we got 1 over 8 to 1, and the other one we get 27. So that's all about question number 3. Let's quickly move on to question number 4. Sorry. So on question number 4, 9 to the power of 1, we get 9. 9 to the power of 0, we get 1. And 9 plus 1, we get 10. I think that's simple and straightforward. On the next question, remember we said if I say a over b in brackets the power of m, this is the same as a to the power of m over b to the power of m. So here, this is the same as 1 to the power of half over 9 to the power of half. And 1 to the power of half, remember, if I say a to the power of half, this is the same as the square root of a. So 1 to the power of half, this is the same as the square root of 1. 9 to the power of half, the same as the square root of 9. In the square root of 1, a number that was multiplied by itself to give 1 is just 1. A number that was multiplied by itself twice to give 9 is 3. So our answer is 1 over 3. That's all about question number 4. Let's quickly move on to question number 5. Again, so simple. 4 to the power of 0 is 1 plus 4, and we get 5. So our answer is 5. On the next problem, 1 over 4 in brackets the power of negative 2, applying the laws of negative powers. Remember, a to the power minus m is the same as 1 over a to the power of positive m. So here, this is the same as 1 over, we keep 1 over 4 as it is, but to the power of positive 2. So this is the same as 1 over, what is 1 squared? You get 1. What is 4 squared? You get 16. So in other words, this is the same as 1 divided by 1 over 16, which is the same as 1 times 16 over 1. And this gives us 16. So this is our solution. So now 5 to the power of 0, we get 1 minus, and 5 to the power of negative 1. So here we know that a to the, any number is the power of 0, it gives us 1. And also know that a to the power of negative m is the same as 1 over a to the power of positive m. So you can apply that law here. What is 5 to the power of negative 1? It's 1 over 5 to the power of positive 1. So here we are looking at 1 minus 1 over 5. Remember, 1 is the same as 1 over 1. So common denominator, it's 5. 1 into 5, 5 times 1, you get 5. 5 into 5, 1 times minus 1, you get minus 1. So the answer is 4 over 5. So 4 over 5 is our solution. The next question, so on the next question, you say 5 times x cubed. Everything is to the power of 2. There's a law which says when 2 or more numbers are multiplied together, right, and raised to a certain power, what you need to do is to raise each number to that power. Like here, if A and B is multiplying each other and raised to a certain power, you need to raise each number to that power. Another thing that I want to quickly say is, don't ever think that if I say AB to the power of M, don't think that is the same as AB to the power of M. This is not the same. AB in brackets to the power of M, it means A is to the power of M and B is also to the power of M. But if I simply say AB and put M to the power of M, only B is to the power of M, not A. So this is completely not the same. So here we've got 5, which is multiplying with x cubed, and everything is raised to the power of 2. So we need to raise each number to that power. So this is the same as 5 to the power of 2, and then x to the power of 3 to the power of 2. So what is 5 to the power of 2? 5 times 5, we get 25. And what is x to the power of 3 to the power of 2? There is another law which says when a power is raised to a power, for example, a to the power of m to the power of n, you keep the base and you multiply the powers. So here, we keep the base, we multiply the power. 2 times 3, we get 6. So the answer is 25x to the power of 6. It's 25x to the power of 6. That's how we're supposed to tackle 6b. Let's quickly move on to another question, question number 7. So on question number 7, we've got 8 to the power 2 over 3. See, these questions are just repeating, guys. Once you've mastered a concept, it is very easy for you to ambush every question that might be examined on that particular topic. I've extracted these questions, as I've said, from different examination papers from all the way 2002, 2003, 2004. But look at these questions. The questions are just uniform. We're just using the same concepts to tackle these problems. A to the power of 2 over 3 is the same as A to the power 1 over 3 to the power of 2. Why did we have to take 2 out and leave 1 over 3? Because we know that if the power is 1 over 2, it means square root. If the power is 1 over 3, it means cube root. Like in this case, we are looking for the cube root of 8. Remember, we did cube numbers, square roots, cube roots back then in the module for working with numbers. We know that the cube root of 8, we are looking for that number when multiplied by itself 3 times gives 8. And that number, indeed, it is 2 to the power of that 2, which was already there. So this is now a 2 times 2, which gives us 4. So indeed, that's the correct answer. Okay, let's quickly move on to the next part. 1 over 6 in brackets, the power of minus 2. This is the same as 1 over 6 by applying the laws of negative powers to the power of positive 2. So this is 1 over, what is 1 to the power of 2? We get 1. 1 to the power of 6, we get 6. So in other words, this is 1 divided by 1 over 6. 1 divided by 1 over 36. Sorry, when you say 6 squared, you get 36. So it's 1 divided by 1 over 36. So which is the same as 1 times 36 over 1, which straight away gives us 36 as the solution. So again, you get a mark for that. Let's quickly move on to another question. Question number 8. So 1 over 4 to the power of negative 2. It seems like these questions are repeating, but this is not my problem. That's a clear sign to show that what you're also going to write in your exam is a repetition of what have been examined before. Like these questions, see, these questions, they're just repeating themselves. As I've said, I've extracted them from different papers and master the concept and see how we are going to show the exam flames. You are not the one who's going to see flames in the exam, but it is the exam that is going to see flames. So master the concept. So what you are going to do in this case, it's a matter of applying the law of negative powers. Remember, a to the power of negative m is the same as 1 over a to the power of positive m. I've said that concept now and again. So this is the same as 1 over 4 to the power of 2, which is equal to, how do we simplify 1 over 4 to the power of 2? Imagine if you've got something like a over b, everything to the power of m. Below it says raise each number to that power. So in this case, we keep this 1, and 1 squared we get 1, and 4 squared we get 16. So practically this is the same as 1 divided by 1 over 16. And we can keep the first and multiply by the reciprocal of the second, which gives us 16 as our final answer. And here can keep the 64 to the power 1 over 3 to the power of 2. Remember, I said that if I say a to the power of m over n, always keep it as a to the power 1 over n, put the m outside. Why? Because it's easy to find the nth root of a number. So likewise here, we know that it's going to be very easy for us to find the cube root of 64. That number, so we're looking for that number that when multiplied by itself 3 times, it gives us 64. And that number is 4. If you say 4 times 4 times 4, you get 64. So the cube root of 64 is 4 to the power of this 2. And our answer straight away again is 16. So 16 again is our answer. This is an interesting. Imagine if an exam you get 16 on part A, you got 16 again on part B, you start doubting your answers. You know, these examiners, they want to test your intelligence. All right, so here we want to simplify 4x squared y to the power of 9 all over x to the power of 4 divided x to the power of 4 y, everything to the power of half. So what you have to do in this case, you need to consider BIDMAS. Please simplify brackets first before you do anything with the indices. So inside the brackets here, we can see clearly that this x squared can cancel another x to the power 4. Students, they tend to confuse themselves. Remember, if I say x squared divided by x to the power 4, this is the same as x times x, but over x times another x times another x. So as a matter of cancellation, these 2 x's on top, they cancel the other 2 x's below. Then you remain with the 2 x's below. So here we say the 2 x's that are on top, let them cancel with the other 2 x's that are below. Then you remain with the 2 x's below. Here there's a 1y below and there are 9 y's on top. So let's cancel those another y and remain with y to the power of 8 on top. So after simplifying here, straight away we have 4y to the power of 8 over x squared. Everything is now to the power of half. So if you go to the next step, you can see clearly that after applying that law, which says when 2 or more numbers are divided and raised to a certain power, raise each number to that power. So straight away here, let's raise 4y to the power of 8 to the power of half, and also x to the power of 2 to the power of half. Right? So here, 4y to the power of 8 to the power of half, we are multiplying 2 numbers together and raise them to a certain power. So you need to raise each number to that power. Obeying that law, it says, if you say ab to the power of m, this is the same as a to the power of m, b to the power of m. So here is 4y to the power of 8 to the power of half. This is the same as 4 to the power of half times y to the power of 8 to the power of half, all over x to the power of 2 to the power of half. This is the same as x to the power of 2 to the power of half. So this is equal to 4 to the power of half, we get 2. Y to the power of 8 to the power of half is the same as y. What is y to the power of 2 to the power of half? There is a law that says when a power is raised to a power, keep the base and you multiply the powers. So y to the power of 8 to the power of half is the same as y to the power of 8 times half, which gives us 4. All over, what is x to the power of 2 to the power of half? Again, apply this law. You use a power raised to a power, keep the base and multiply the powers. What is 2 times half? You get 1. So the answer is 2y to the power of 4 over x to the power of 1. That's our solution in this case. Let us quickly move on to another question number 9. So question number 9 is 3/8 to the power 4 to the power of 2. So we've got two numbers here, a and 8 to the power 4, that are multiplied together and raised to the power of 2. So let's raise each number to that power. This is the same as 3 to the power of 2, 8 to the power of 4 to the power of 2. We have raised each number to that power. And then the next thing, what's 3 to the power of 2? It means 3 times 3, and this gives us 9. And what is 8 to the power of 4 to the power of 2? Remember I said when the power is raised to a power, just keep the base and multiply the powers. So in this case, we're going to keep the base and multiply the powers, which is 4 times 2, and this gives us 8. So the answer here is 9a to the power of 8. This problem, again, they've repeated it. This is the same as 1 over 4 to the power of 2, which is the same as 1 over 1 to the power of 2, we get 1, and 4 to the power of 2, we get 16. So this is the same as 1 divided by 1 over 16, which gives us 1 times 16 over 1, and this gives us 16 as, again, our answer. Okay, let's quickly look at another question, which is question which is part C and part D. On part C, they say x cubed is equivalent to 27 to the power of 0. So the same as x cubed is equal to 27 to the power of 0 is the same as 1. So now, you can take cube roots both sides. So you can take a cube root here. You can also take a cube root here. So this and this cancels. So x is equivalent to 1. So our x value is basically equal to 1. So we also have this question, which is 12 to the power half. So this is basically the square root of 12 over 3 to the power 1 over 2 is basically the same as 3 to the power of half to the power of 3. So this is the same as the square root of 12 over 3 to the power of half is also the same as the square root of 3 to the power of 3. Remember, 12 is the same as 4 times 3. And all over the square root of 3 to the power of 3, which is the same as square root of 4 times square root of 3 is the same as the square root of 4 times the square root of 3, all over the square root of 3 in brackets the power of 3. So now we can do the cancellation here. You can see that here we would, so remember, if you say the square root of 3 to the power of 3, this is basically the same as the square root of 3 times another square root of 3 times another square root of 3. That's what it means by the square root of 3 cubed. So clearly you can see that this is square root of 3 and this square root of 3 cancels. And what we remain with is the square root of 4 over the square root of 3 times the square root of 3. The square root of 4 is 2. And the square root of a number times the square root of a number, you get that number, right? So imagine if the square root of 3 times the square root of 3, this is the square root of 3 in brackets squared, and this squared and the square root cancel. So you basically get 3. So our answer is 2 over 3. So, so that's it. The next question, which is question number 10, it's written 8 to the power of 3 in the form 2 to the power of k. Remember, 8 to the power of 3. 8 itself is the same as 2 to the power of 3. That's 8 to the power of the 3 that was already there. So this is the same as 2 to the power of 9. So in the form 2k is the same as 2 to the power of 9. And on this one, which requires evaluation, we rather factorize the numerator. So there's 9, there's 3, rather factor out 3. 2 to the power of 12, 2 to the power of 10, but here there's a 2 to the power of 8. Let's just factor out 2 to the power of 8. 3 into 9, we get 3, and 2 to the power of 8 into 2 to the power of 12, we get a 2 to the power 4. Minus 3 and the 3 cancels, so you get 1 times 2 to the power of 8 into 2 to the power of 10, we get 2 to the power of 2. All over 3 times 2 to the power of 8. In an attempt to cancel this and this cancels, and what you remain with is 3 times 2 to the power of 4 is 16 minus 1 times 2 to the power of 4 is 4. So 3 times 16 you get 48 minus 4, and straight away our answer is 44. That's the solution in this case. Okay. So you can move on as far as question number 11. So 4 to the power of minus 2 is the same as 1 over 4 to the power of 2, which is 1 over 16. So the answer is 1 over 16. For this one, let's simplify brackets first. So this x will cancel with another x here, then remember the x2 on the denominator, y to the power of 2 into y to the power of 6, and remember the y to the power of 4 on the numerator. So our answer is 9y to the power of 6 divided by x squared. Everything is to the power of half. So this is the same as 9y squared to the power of half all over x squared to the power of half. So this is the same as 9 to the power of half, y to the power of 2 to the power of half over x to the power of 2 to the power of half. So 9 to the power of half, we get 3. That's the square root of 9. Y to the power of 2 to the power of half, we get y to the power of 1. X to the power of 2 to the power of half, we get x to the power of 1, which is basically 3y all over x. That's our solution. So our solution is 3y over x. Let's quickly move on to another problem, probably the last one. So 5 to the power of 0, you get 1, 5 to the power of 2, you get 25, and then the answer is 26. 36 to the power of half means the square root of 36, which gives us 6, and 2 to the power of 2 over 3 to the power of 6. We can keep the base, I'll multiply the powers. What is 2 over 3 times 6? We get 2 to the power. What is 2 over 3 times 6? 3 into 6, you get 2. 2 times 2, we get 4. So the answer is 2 over 4, which is equivalent to 2 times 2 times 2 times 2, which gives us 16. So these are basically our solutions. Okay, let's move on to another question. Here we have a part B. Seems a little bit interesting. So 1 over 3 to the power of k is equal to 9. So remember 1 over 3 is the same as 3 to the power of minus 1 to the power of k, and 9 is the same as 3 to the power of 2. So 3 to the power of minus k is the same as 3 to the power of 2. So if the bases are the same, then the powers must also be the same. So if we equate the powers here, you can see that minus k is equal to 2, and k is minus 2. So k is minus 2. That's the solution on this problem. Let's look at the last, not the last as such. Let me give you another one. The square root of 121 is basically 11. The cube root of minus 27 is basically minus 3. There's no problem with these problems. Let's look at 2 to the power of 3 is giving us 8. 3 to the power of 2 gives us 9. 4 to the power of 0 gives us 1. 5 to the power of minus 1 gives us 1 over 5. So if we start with the smallest, 1 over 5 to the power of minus 1 is the smallest. 5 to the power of minus 1 is the smallest, followed by 4 to the power of 0, followed by 2 to the power of 3, lastly by 3 squared. So we've done proper arrangement. 16 to the power 2 over 3 here. 16 to the power 3 over 2 is the same as 16 to the power 1 over 2 to the power of 3. 16 to the power of half means the square root of 16 to the power of 3. So it's going to be 4 to the power of 3, which gives us 64. So the answer here is 64. And we get all the marks. I promised that this is the last question, but I realized that it wasn't. But now we have reached at the end of all these questions. Definitely, I wish you all the best, guys.